This is Mr. Widmeyer getting you some review on the Calculus Summer Review packet. Today specifically we'll be looking at, or this video I should say, specifically we'll be looking at letter A, where we're going to just simply factor and simplify these given problems. Again, this is the more thorough video where I'm going to go through all these problems. We will have gone through some of these problems in class, but not all of them. So here's the full explanation for everything. All right, so starting out, again, we are asked to factor and simplify. Remember that factoring can mean a lot of different things in different situations. So, different strategies that you use. So that includes like GCF. That includes, quadratic factoring. It can be factoring by grouping. Okay, etc. You can also use, like sum of cubes, sum or difference of cubes, and stuff like that. Okay, so these are all different ways, that we'll factor. That word factor can mean lots of different things. So we want to be able to do all these things. And number one, okay, looking at this one, looking at the numerator first, we see that we have a quadratic there that's got a lead coefficient of 1, so we can just use the product sum method where we look for two numbers that multiply to make negative 12 and add to make the middle term of 1 there. And so that's going to be x plus 4. And x minus 3, okay? And then in the denominator, all right, we can see here that there's a GCF that we can factor out of all three of those terms. So what is the GCF? Well, it's 2x. And so if we take out a 2x, we'll be left with an x squared minus an 8x and then plus a 15. Okay, now our leftover here is a quadratic which will also factor. And so again, since the lead coefficient is 1, we can just use the product sum method where we're looking for two numbers that multiply to 15 and add to make negative 8. And that's going to be x minus 5 and x minus 3. Okay, now at this point we can simplify, but we have to be a little bit careful here. Okay, so the tendency you might say is like, oh, we can just cancel out the x minus 3's and just say that the final answer here is x plus 4 over 2x times x minus 5. Now, there's one important subtlety here, though, that this is not exactly equal to this, even though we just said that it is, right? We have this equal sign here indicating that this and this are equal, but they're not exactly equal. Why? Because we can see that if I plugged a 3 into this rational expression here, I would end up with 0 over 0. If I plug a 3 into this rational expression, I would not end up with a 0 over 0. I would get an answer. I'd get a number. That would be okay. Okay, and so we can't say these two things are equal unless we put a comma here and say x not equal to 3. So this is just a little stipulation. Sometimes we often will overlook this kind of thing. Maybe in previous math classes you overlooked it, but in calculus it's going to be super important that we also pay attention to these fine details. Okay, so now we can for sure say that these things are equal. All right, number 2. So in number 2, I see here that we have a perfect cube and subtracting a 64. Now, as soon as I see two things here, and one of them is already a perfect cube, I immediately think in my head, is this other thing a perfect cube? Is 64 perfect cubed? And the answer is it is a perfect cube, right? And so we're going to use the difference or the difference of cubes formula here. I'll write that out. So if you have a cubed plus or minus b cubed, so this formula you can use for either adding a sum of cubes or a difference of cubes here. Oops, I don't need that parentheses. It would be then a plus or minus b. And it'll be, a squared minus plus, so the sign changes, ab, and then plus b squared, like that. Okay, so if you have a sum of cubes, then it's going to be a plus b, and then a squared minus ab plus b squared. If you have a difference of cubes, it'll be a cubed minus b cubed, it'll be a minus b then, and it'll be a squared plus ab plus b squared. So in this case, right, our a is going to be x, and so we'll have just x minus 4, and then x squared plus 4x plus 16, like that. And then in the denominator, this is a difference of squares, which also has factors as well, and it's going to be factoring to x minus 4 times x plus 4. And again, we see here that we can cancel these two things out. Okay, now you also see here we have a quadratic, but this quadratic does not factor. Okay, and in general, a difference or sum of cubes, the quadratic that remains at the end will not be factorable. Okay, but still check it just to make sure, right? But anyway, x minus 4 is canceled, so we can say that again that our final simplified answer here is going to be x squared plus 4x plus 16 over x plus 4, but technically they're not exactly equal. We have to put comma x not equal to positive 4. Again, because if I were to put a positive 4 into this problem, I would get 0 over 0, which is also known as indeterminate form. If I put a 4 in here, I would get no problems. So we want to specify these two things. If this is going to be equal to this, they have to be equal everywhere. Okay, so we'll just stipulate then that x cannot be 4. Okay, like that. All right, number 3. All right, so we'll look here and see if this factors. So in this case, right, we have a lead coefficient of 2, and there's no way to factor that out. So there's a couple different strategies you can use. One way is to just guess and check, right? We know that we need to get a 2x squared. The only way to really multiply to do that is a 2x and an x. And then it's just a matter of figuring, okay, what two numbers multiply to make negative 15, right? So we can say, like, I don't know, negative 5 and like positive 3 here. But then we also need to add to make negative 13. But be careful, right? This negative 5 will multiply with x, but this 3 will multiply with a 2, okay? So is that right? Well, negative 5 plus 6 is not going to make the negative 13. So no, I put those in the wrong spot, okay? So let's see here. Let's instead try minus 5 and then plus 3 like that. No, it doesn't quite work either. Minus 10 plus 3 does not work either. Let's see here. How about minus 15 plus 1? That one does work, right? Negative 15x and then plus 2x will give us that minus 13x that we're looking for there. So there's the factoring. Another way to do this is to use something called the AC method, where you take the a of 2 and the c of negative 15, and you multiply them. So that would be negative 30. And then you look for two numbers that multiply to make negative 30, and then add to make that middle term of negative 13. What two numbers would those be? It would be negative 15 and positive 2. And then you break up the middle term of this quadratic here, like so, using those two numbers you just came up with. Okay, and then group factor by grouping. So group the first two, group the second two. From that first group, we can take out an x. From the second group, there's nothing to take out, so we can just say there's a 1. And you'll notice that you have the same leftovers. We can then further factor here, and we'll end up with the 2x minus 15 times the x plus 1. And voila, that's the exact answer we had from before, too. They're the same. Okay, so two different strategies there. All right, you can kind of do like a guess and check, like with this one. Okay. Or you can do the AC method. Again, AC method, you take the A, multiply it with the C. In this case, we get negative 30. You then look for two numbers that multiply to that negative 30, but then add to the middle term, negative 13. Those two numbers you use to break up the middle term, okay, like I did right there, and then you factor by grouping. And you should end up with the same kind of answer with the grouping, with the factoring as normal. All right, number 4, okay, it's not a quadratic, but it's in a quadratic form, right? We have, like, really you can think of this as like t squared squared minus 13 t squared, right, plus 36. Or maybe put more bluntly, something squared minus 13 times that same something plus 36. And so we can just factor this like it's a quadratic. We're looking for two numbers that multiply to make 36, but add to make negative 13, because, again, our lead coefficient there is 1. So what will those two numbers be? Well, it would be the blank minus 4 and the blank minus 9. But in this case, our blank, right, is not just x, it was the t squared. So this is going to be t squared minus 4 and t squared minus 9. Okay, and we factored. We're done, right? No, because these are both differences of squares, and so they can further factor to be t minus 2 and t plus 2. And this would be t minus 3 and t plus 3. Okay, so be careful there, right? We did say to factor fully. Okay, so I didn't circle any of these here. Okay, 5 and 6. Now, number 5, okay, at first glance here, it might be not clear about what to do, right? So one option that we have here is that since we can look at this and see, is there a GCF? Well, all of these terms have an x, but it's not exactly clear what power of x we can factor out here. Well, let's do a simpler problem real quick here. Let's say I have like x cubed plus, I don't know, 2x squared plus 3x or something like that, okay? What power of x can I take out from this problem? Just x, right? So I'm kind of limited here by taking out the lowest power of x, right? I couldn't take out an x squared because this doesn't have an x squared enough, you know, to take out for an x squared to be taken out. right? So likewise here with our expression here, the lowest power is what? X to the 1/2. So that's going to be what we take out. So we're going to factor out an x to the 1/2. And again, that might seem kind of strange. Remember that factoring is really division. So we're taking x to the 5/2 and we're dividing out x to the 1/2. So when you divide, what do you do with your exponents? You subtract. So this would be x to the 4/2, or in other words, x to the 2. Then take the x to the 1/2 out of this, again, subtracting 1/2. So 3/2 take away 1/2 will be x to the 2/2, or just 1, or just x. And then take out the 1/2, x to the 1/2 here, we'll just have a 6. And then this factors further, right? So let's do that real quick. Again, it's just a simple quadratic, right? Like so. And so there's our simplified answer there, or factored and simplified answer. Last one here, I'm going to have to undo my circle so I can see it better. Again, we have two things really that are being added together here, right? This is one product plus this product. And so we want to look for, again, a GCF. You can see that both have an x minus 3 factor. Both also have a 2x plus 1 factor. What is the most amount of x minus 3s we can take out from both groups here? Well, it would be x minus 3 squared. What's the most amount of 2x plus 1s we can take out from each group? 2x plus 1 squared. Again, we're limited by the lower power. If I take out an x minus 3 squared and a 2x plus 1 squared from this first term here, what's left? Well, just a 2x plus 1, right? Maybe I should use a different set of parentheses. There we go. And if I take an x minus 3 squared and a 2x plus 1 squared out of here, what's left? Well, just an x minus 3. And then we can kind of combine like terms in here to finish our simplification. And so we'll get 3x minus 2. And there is our final factored and simplified answer. In the next video, we'll take a look at letter B. Thanks for watching, guys.